Let's recap what you have learned at O-level on ionic bond. In ionic bond, the cations and anions are held together by strong electrostatic attraction forces, as both ions are oppositely charged. These strong electrostatic attraction forces enable the ions to be closely packed. As a consequence, ionic compound is hard and brittle. They have high melting point and boiling point. In the presence of water, ionic compound will be able to dissolve and the ions break up, as shown in the diagram here. Finally, ionic compounds in aqueous state or molten state would be able to conduct electricity, but not in the case of solid state, as the ions are not mobile and free to conduct electricity. At the A level, the strength of an ionic bond is being quantified by examining the magnitude of the lattice energy. So what is lattice energy? Lattice energy is defined as the amount of energy released when 1 mole of ionic compound, for this case sodium chloride, is being produced from its gaseous ions. And the magnitude of the lattice energy depends on the charge of the cation, charge of the anion, and the inter-ionic distance between the ions, as indicated in this diagram. Now let us compare the melting point of magnesium oxide and sodium chloride by examining its lattice energy. So for example, when we compare the melting point of magnesium oxide and sodium chloride, magnesium oxide has a higher melting point because its magnitude of the lattice energy is higher. The reason is because the charge of Mg2 plus is twice that of Na plus, charge of O2 minus is twice that of Cl minus, and finally, the inter-ionic distance between the anion and cation is smaller. Finally, for cross and dot diagram for ionic compound, at the A level, you no longer need to draw a circle to represent the electron shell. You will merely depict the valence electrons by cross and dot. And cross, in this case, the cross are electrons from the sodium that's been donated to the chlorine atom.